Hi, this is the first video in a series covering forces and Newton's laws and the problems that you're likely to encounter along that journey. The first video here is largely just focused on the basics of Newton's second law. That's saying that the total forces acting along one direction on an object have to equal the product of the mass of that object times the acceleration that that object is experiencing as a result of those forces. So in class, we did a few of these problems as practice, but I'm going to add to that list. And I'm going to start with this second example right here on the second page of your packet notes. Now, in this situation, we have an unknown force C that's pushing up on this object and a force of 200 newtons acting downwards on it, resulting in a net force or total force of 900 newtons acting upwards on this crate. Now the net force here means that whatever C is, if we take away 200 from it, the total of those two, or the difference between them, must be 900 newtons. You could probably do that in your head, but we're going to write it out explicitly just in case you need that tool later. So the first thing is that the forces cannot be balanced here because, well, it's got a net force. If the forces are balanced, you would expect something like a net force of 0, as you see up here. Now, to find the unknown force, that's force C, what I'm going to do is write out an expression for the net force. That would be that the total force here is C upwards plus the downward force, which I'm going to say is negative 200 newtons. Okay? And now we can sub in for the net force because we have it. So we'll say that's 900 newtons equals C minus 200. And so by adding 200 to both sides, we will get C on its own, in which case C is going to equal 1100 newtons. And that is our unknown force. Now, if we want to find acceleration of this crate, well, we already have the net force, so most of our work is already done, because the only other thing we need is the mass, and, well, we've got that too. So over here, we're going to write out Newton's second law in full. It's going to be that the net force equals the mass of the crate times the acceleration that we are solving for. So in this case, again, we're going to sub everything in. So we've got 900 newtons over here, and all of that's going to equal a mass of 20 kilograms times the acceleration we're solving for. Then if we divide both sides by 20, we'll end up with an acceleration of 45 meters per second squared, which sounds like a lot, and it is. That's a pretty intense acceleration for a crate to be moving at. So I don't know what's causing this, but more power to them. So the last thing here is, well, we'll say that this acceleration is upward, and that matters for figuring out this last column here, which is determining whether it's speeding up, slowing down, or moving at a constant velocity. Well, we're told at the very beginning that it's moving upward. That means its initial velocity over here is upwards. Now, in that same vein, we could say the acceleration is also upwards. Now, the only situation in which this crate would be moving at a constant velocity is if it is in equilibrium, or if the forces are balanced. That's when the net force is 0 newtons. The fact that the velocity and the acceleration are in the same direction means that you can imagine this as like you are pushing an object in the same direction that it's already moving. This would be a situation in which you'd be causing the object to speed up, because you're adding more to the velocity that's already there. All right, and that's a problem done. Next, we're going to move on to a slightly different problem, although it's the same setup, so a lot of the numbers will be pretty familiar. In this case, we are not given the net force, but we're given the acceleration, which is 5 meters per second squared upward. So what we'll do here is we'll say, well, so we have acceleration, it's that. We have the mass, which is 20 kilograms. So say we wanted to find the net force, which is in this column right here. Well, we can use Newton's second law to solve for that. So we'd say the net force is equal to the mass of the crate times its acceleration. We have both of these quantities, so we can just keep everything on that side. And so we'll say the net force is equal to 20 kilograms times the acceleration, which is 5 meters per second squared. And so our net force here is going to be 100 newtons. and the acceleration is upward, so the force will inherit that direction. So in total, we've got a net force of 100 newtons upwards on this crate. Now, because we have a net force, that means that the forces are not balanced. That's what this column was asking before. And so finally, we need to figure out what this unknown force C is. So for that, we're going to write a different expression for net force, which is the same thing from before, which is C minus 200 newtons. Okay. And because we now have that net force quantity, we'll go ahead and sub that in as well. It'll be 100 equals C minus 200. And so again, if we add 200 to both sides and to get C on its own, we will end up finding that C must equal 300 newtons for this crate, which makes sense because 300 minus 200 gives us that total force again, which is 100 newtons. Cool. And finally, well, our acceleration is upward. The crate itself is moving upward. So initial velocity is upward. Acceleration is also upward. So again, because the acceleration is kind of egging this velocity on, it will be speeding up in this situation. Cool. And finally, we've got kind of the big kahuna here. Where we've got a force that's acting at a distance, or sorry, at an angle, with respect to two other forces, J and K, that we don't know, and we'll have to find out in this problem. So our given information here are that we've got a 6 kilogram crate, and it's moving to the right. That would be our initial velocity. And we're also told the net force acting on this crate, which is 40 newtons to the left in total. All right. So where to begin with this one is really just to first state that, yeah, we are going to expect to have some acceleration here. The forces do not balance out. From that, we have a couple of options. First off, we've got to split everything into horizontal and vertical. In order to do that, well, we should first acknowledge that, well, this 100 Newton force here is opposing these other two forces that are already in the vertical and horizontal directions. So if we bring these two forces out here, we can find the x component and the y component of this 100 Newton force by using our usual trigonometry tricks. So this force over here, let's go ahead and find that. It would be 100 newtons times the cosine for horizontal of 36.87. And so this force is going to equal about 80 newtons to the right, if you were to find that. Secondly, this force over here, I'm going to solve for it over here, would be 100 newtons times sine of 36.87. And if you were to solve for that one, you should get a force of about 60 newtons upwards. Okay, so with those two forces, we can now go back to our usual business from before. All of the scary trig stuff is gone. The only other thing that's different about this problem as opposed to the other two is that we add in this extra horizontal direction. So I'm going to split things up into horizontal and vertical, and I'm going to focus on the horizontal first. So horizontally, our net force has to equal an 80 Newton force to the right minus an unknown force J that we've got to solve for. All right, and so our net force is in the horizontal direction. We're told that we have a leftward or negative 40 Newton force in total. So I'm going to sub that in here and add in everything else minus J. And so in order to solve for J here, well, we can move this J over to the other side and then add 40 to this 80. And so we should find that J is going to equal about 120 newtons to the left. And that makes sense because if we were to add or subtract 80 from 120, we should get a leftward 40 Newton force. Oh, and I guess I should add my units there. Don't forget those. All right. Next, we need to find vector k. And this one is fairly easy because in this case, the net forces in this direction have to be 0 in the y direction. Now, if the forces cancel out and they really only have 2 of them, then all you really need to do here is say, well, we've got a 60 Newton force acting upwards. So it makes sense that K should be the same thing. It should be a 60 Newton force just downwards. So you can keep it at that and move on from there. So those are our 2 unknown forces. Now, to finish this off, we're going to find an acceleration, and again, that's fairly straightforward. If we take the net force and equal it to the mass times the acceleration with Newton's second law, well, our net force is negative 40 newtons, and that's going to equal a 6 kilogram crate times the acceleration, and 40 divided by 6 is about 6.6, give or take. So the acceleration is going to equal negative 6.6 meters per second squared. Or in other words, it'll be leftwards. Now, if this thing is speeding up, it would mean that the acceleration is going in the same direction as the velocity, while this crate initially is moving to the right, but our acceleration is acting to the left. So if they're opposing each other, then this is like if something is rolling towards you and you're having to apply a force in the opposite direction of its motion. In that situation, this thing would be slowing down, meaning the acceleration is going against the velocity. It's decreasing it until it starts increasing again. And that's a pretty good variety of force problems to really tackle with these concepts. Now, moving on from there, we're going to keep adding more and more levels of complexity to this, but all of the stuff that you're doing on this page are the absolute essentials that will set you up really well for all of the stuff that you'll be tackling in the future. So I hope this video helped, and I will catch you on the next one. Peace.